see first global sea level changes. And we'll start with climate, glaciations. So, if we have ocean and then land or continent here, during, let's say, normal times, there would be climate that is somewhat similar to modern day climate. There will be small amount of ice somewhere in high mountains or high latitudes, and the rest of water on our planet will be in liquid state and stay in ocean, making ocean relatively high in respect to when climate gets really cold, what happens when snow precipitation starts staying on land and making extensive ice sheets that cover not only polar areas but high mountains, and the amount of ice that is staying on land, that is not returning back to ocean, increases over time so much that we have global drop in sea level. So during glaciations, large amount of water in water cycle is not returning back to its original spot. Most of it starts from ocean evaporating, going into clouds, coming down as precipitation. Some of that precipitation returns back by rivers or groundwater to the ocean, but some of it doesn't, because it stays tied in ice on ice caps and ice sheets that sometimes last for 10,000, 20,000, maybe 100,000 years. All those Milankovitch cycles gives us an idea how long those ice episodes last. So that's what happens with glaciation. And they happen, sea level drops, and much more land is exposed. During the peak of last ice age, the latest one happened about 20,000 years ago. That was the last peak in glaciation. Sea level was about 130 meters lower than modern sea level. That's a lot, 130 meters. You expose a lot of continental shelves. There was a land bridge between Asia and North America during that time, because there was a not very deep ocean separating the two, and then when it freezes, makes land connection easy. The second tectonic rates of C4 spreading are very important, because when seafloor is spreading rapidly, the volume of mid-oceanic ridges become enormous. They become not sharp and tall mountains like mid-Atlantic ridge today, but they become broad sea rises like East Pacific rise. It's not pointy, but it is broad and voluminous. So if every spreading center in modern ocean behaves like East Pacific rise, sea level would be probably 20, 30, 50 meters higher than it is today, but it doesn't. So during, here's the land, here's the ocean, here's the land. During times of relatively slow sea floor spreading, which we may say modern Earth is more or less somewhere in this phase of fairly low seafloor spreading, because we had many parts of modern world ocean, like Atlantic Ocean, most of Indian Ocean, some parts of Pacific Ocean, Arctic Ocean. They have fairly slow rates of seafloor spreading. We are talking here about inch or so per year. That's fairly low, is that right? The only exception is East Pacific rise that spreads some 3-4 inches a year, so four times faster than other areas. So during these times, lava comes out through the fractures and makes fairly tall but lean mid-oceanic ridges. They have the gap in the middle. This is cartoon, of course. Those are not as pointy as I present them, but you got the point. It is not occupying too much space inside the ocean. Is that right? When seafloor spreading rates start increasing, what we get is very broad and wide mid-oceanic ridge that occupies majority of the ocean and forces water to spill over land. It forces flooding of the continents and rise in sea level, forces transgression. That is, water has only one place to go, to spill over on land. Is that right? Because ocean doesn't have that much volume to hold all the water, because most of ocean is now occupied by those very bulky mid-oceanic ridges. Do you understand that concept? So ocean has certain volume. That volume is occupied by water and whatever else existing in that hole. Is that right? If you have lean mid-oceanic ridges, there's much more room for water to sit in that ocean. If you have bulky mid-oceanic ridge, there is no room for water. It has to go on land. So this fast seafloor spreading happened many times in Earth history. Last time it happened during Cretaceous period of Mesozoic, the youngest part of Mesozoic, about 100 to 80 million years ago, where there was so much spreading and fast rates of spreading in world ocean that water was pushed out, and most of North America was flooded through the center of the continent. So Arctic and Gulf of Mexico were connected. Everything was underwater because big amount of mid-oceanic ridges was forcing water to spill over land and flood many of the continents. So the Cretaceous interior sea, you will hear that maybe later in semester when we talk about Mesozoic era, and in some other classes, maybe in Strat, to understand changes in deposition and phases during those times. Slow rates of seafloor spreading, low sea level generally favors regressions, fast rates of seafloor spreading favor transgressions, high sea level, and it makes some sense when you think about fast rates of seafloor spreading also means so much more volcanism. When you have a lot of volcanism, that means there is a lot of carbon dioxide. When you have a lot of carbon dioxide, that means it's much hotter. When you have it much hotter, there is little chance for ice to survive. So all of those tie up. Is that right? When you have less volcanism, less carbon dioxide, less volume of these mid-oceanic ridges, possibility for ice to exist bigger because climate is cooler and so on. And we will discuss regional Are there any questions about glaciation or rates of seafloor spreading? Does this make sense logically? Everything, if you feel it, understand it logically without breaking your head, you probably understand. I may check you on this and see, do you really understand? It's best to talk with each other, to convince each other, then you know how much you know or you don't know. If you just keep it in your head, you may think you know it, but when time comes to say it, you may not be able. So practice with each other. The regional sea level change affects only small areas, not the entire globe. There are some examples where we see this today. For example, west coast of United States, California, Oregon, they experience regression because tectonics keeps pushing that part of United States or Western America up, and sea level slightly drops because land is coming up. That's right. The easiest to understand is I will erase this and start doing something like this. This is Scandinavia and Western Europe during Ice Age. So this is Scandinavia. This is Middle West Europe. During Ice Age, there was a huge ice sheet that was covering northern Europe, Scandinavia, and neighboring areas. There was a several kilometers thick ice sheet that was loading the land in Scandinavia. Netherlands was not on the ice. It was at the border, bordering this ice sheet. So it was dry land, very harsh, but not under any weight of the ice. As Ice Age come to the end, and these glaciers started melting, what we have is what used to be Netherlands is now covered by shallow sea. What used to be Scandinavia stayed as a dry land above the sea. However, soon after glaciers started melting, what was pressing the land underneath the ice, the process we call isostasy. When you add weight on land, it will compress, it will sag, because it reacts to the weight that's added. when we remove that weight, land starts rebounding. That's isostatic rebound. So Scandinavia grows or rebounds, goes up. Still, even though there is 10,000 years since disappearance of ice, it is still rebounding back and getting drier and drier, more and more above sea level. In some parts, several hundred to 300 meters above its original position. In parts of the Hudson Bay, Canada, where there was a huge, even bigger mass of ice, I think they have, as I understood, more than 600 feet of rebound after the end of Ice Age. So that's a lot of ground going up, readjusting its position. As this side is going up, it's like seesaw. This goes up. The Netherlands, that is opposing of the Scandinavia, is actually going down, because that's what isostasy does. It cannot go when ice was pressing this down, this was going slightly up. Now we are back into rising Scandinavia and lowering Netherlands. That's why Netherlands has problems with invasion of the sea. They are fighting the sea rising continuously, making those multiple drainage channels with windmills that help them drain and remove the rising seawater from their land. So this is only affecting fairly small part of the world. As I mentioned, Scandinavia, similarly Canada is rising, and I don't know which areas are flooding. Maybe all the bordering parts of northeastern United States, that should be a little less rising and more sinking in terms of isostasy and rebound. Let's go through a few more slides. Are there any questions about these global and regional sea level rises and what's causing them? Okay. No? Already.